Hello, everyone. Welcome to Theo-MathProblemSolver. So, in this particular episode, we are going to have a recap on what we've done so far and see how best we've been able to sort of analyze things and see how we can, sort of answer some of the questions that I've you know, put on here. So let's see how we can tackle the first question. So we have y equal to, so we have y, let me use a different pencil. So we have y equal to 3 to the power x. So how do we find it, dy dx of this exponential function? So our exponential function, so will just be your y prime, will just going to be what? Just going to be the natural log of 3, then we multiply it by 3 to the power x. Okay, so on that note, our solution will be the A. So that is it. All right. So for the problem 2, so we have f of x equal to the natural log of x squared plus x. So how do we find this derivative? A derivative, what happens is that we differentiate the input. Okay, so we differentiate the input, then divided by the input. Okay, very important. So with that, you're going to have 2x plus 1 over x squared plus x. So on that note, our result will be what? Our result will be the D. Is that okay? Good. So let's move on. Now, how do we differentiate this? The product of two functions. So we use the product rule. So what happens is that our dy dx. So what happens? We can cover this. Then we differentiate e to the power 2x. Then plus, then we cover 2x, then differentiate x7 to the power, sorry, x to the power 7. And when we do arithmetic, we should get something beautiful as this. So with that, we should have, which one as our result? So we should have our A as our final result. All right. So how do we find the maximum or the absolute maximum and the minimum of this particular function over the closed interval? So the first thing to do is to find our first derivative. So our first derivative will be what? Will be 2x minus 4. Then we set this to 0. So it means that our x will be 2, our critical point will be 2. Then what happens? We're going to have to find the second derivative, okay? Our second derivative will be 2. Is that okay? And this is, even when we plug in the critical point, this result will be positive. So which implies we're going to have a relative minimum, right? So we're going to have a relative minimum. But then we have to plug in, you know, so remember that with this one, we also have to consider we also have to consider the range, right? So we plug in 0 into the main function and you will have what? 11. And when you plug in 3 in the main function, you should have what? What do we get if you plug in 3 in the main function? So you're going to have 3 squared minus plus 11. And that should give us what? 9 minus 12 plus 11. And that should give us what? 9 minus that should give us minus 3. Minus 3 plus. So 9 minus 12 will give us the minus 3, right? And minus 3 plus 12 should give us what? 8, right? All right. Now we also have to find the f of 2. Is that okay? Now when you plug in 2 into that, you have what? So 2 squared minus 4, 2 plus 11, and that should give us what? We have 4 minus what? 8 plus 11. And that should give us what? 4 minus 8 will give us what? Minus 4 plus 11 should give us what? Should give us 7, right? Is that okay? Should give us 7. All right. So so what happened is that, let me use a different pencil. So what happened is that let's pick the maximum value. So the maximum value here is what? Is 11. And the list of them is what? Let's see. The list of them is what? The list of, so we have 7, and the list is what? Is 7. Okay. So on that note, maximum, our absolute minimum, it is 7, and absolute maximum will be what? Will be 11, right? So our absolute minimum will be 7, and then absolute maximum will be 11. So in that note, our B will be our result. Okay. Good. So let's move on to the next problem. So with the next problem, it is said that suppose the weight of a plant can be estimated to be something as this, to be W equal to 5h squared, where W is weight of the plant in pounds, and the H, it is said that is the height in feet. Okay, so it is said that if the height of the plant is currently 3 feet and is growing at a rate of, so it's currently 3 feet, okay, and it is growing at a rate of 2 feet per year, how fast is the weight of the plant increasing? Okay. Okay. So there are certain salient things that we can, point out over here. So I want us to take note of one or two things. So it is said that if the height of the plant is currently 3 feet and is growing at the rate of 2 feet per year, so it just means that we are going to have our dh, the what? dht as what? Your 2 feet per year. Okay. So we have that. Now, the question is that it says, how fast is the weight of the plant increasing? How fast is the weight of the plant increasing? On that note, so we just find our dW with respect to what? With respect to what? Okay, so maybe what you can do is that you can pause the video and try and see what you will get. So with that, what do we think we should get? So our dW, the what? The what? Is it the H or the T? So the H will be what? That will be 2 times that. That gives us 10. Okay. So 10 H, then the H, the T. Okay. What is your H? Now the H is giving us for 3. Okay. And then your DH, DT was giving us 2. So on that note, we should have what? 60 what? Pounds per year. Okay. 60 pounds per year. So on that note, our result will be C. Is that okay? So this question literally lies on the, the um, rates, okay? Rate of change. So let's take note of that. Now, in question 6, it says that the population of a town is modeled by this nice function, exponential function, where t represent the number of years after the beginning of 2000. How fast is the population growing at the beginning of the year 2006? How fast is growing? So how fast is growing means what is the rate of change? Okay, so our p prime would then be what? So remember how we differentiate the exponential function, okay? So we differentiate the exponent, then multiply the result by the whole thing, okay? So we're going to have 9,000 multiplying point. Okay, so with this, it just means that our result will be what? Our result will be B. Okay, good. What about this particular problem? When it says we're given this as our function, which of the function is true? So since we are seeing something like inflection, what comes to mind? So with inflection, the first thing to do is to find the first derivative, okay? So by finding the first derivative, you're going to have what? 6x squared minus 6, okay? Then we find a second derivative with inflection, find the second derivative, and that gives us what? 12x. Then we set it to 0, okay? So it means that your x is 0. You see? So it means you will just have a point of inflection at only x is equal to 0. Is that okay? So that is going to be our result. What about this nice function? We have to use the implicit differentiation to find our dy dx. So what happens is that we find a differential on both sides. Okay, but then if I were you, I think I would like to pause this video and try and solve it my own. Then after I will compare my result to this. So with that being said, we can just go straight to the point, and that should give us something as this. So at this point, what we just isolate terms with dy dx, okay? So it means our result will be what? Will be the A, okay? Good, good. Now, with this question, we're asked that we want to maximize P equal to 6s plus y, which is subject to this very condition. Now, the easiest way to solve this question is that we can just make y the subject and plug it into the P, okay? So by making y the subject here, or by isolating y from this condition, we'll get what? 3 minus what? X squared. Then we plug it into P, okay? And by plugging that into P, you're going to have something beautiful as this. Now, I want to maximize P. So what do we do? First, we need to find the first derivative, okay? And by finding the first derivative, we're going to have this. Then we set to 0. Then we get x to be what? To be 3, right? Then what do we do next? We find the second derivative. By finding the second derivative, we're going to get what? Minus 2. Right, so which implies that we have maximum here because the second derivative is 0. Okay. Then we plug this, we plug out. Now we know this. Now it is there's that assurance that you have a maximum here. Okay. But then we have to plug it into the main function, which is which is this. We plug the critical point, which is 3, into the main function, and that will give us what? That should give us what? So this is 18 plus 3 minus 9. So 18 plus 3, that is 21. And then 21 minus 9 gives us what? Gives us 12, right? All right, so it just means that our maximum value will just be 12. At this point, if you have not subscribed, please do so. Like my content, put on your notification button so that anytime, I release new content, you'll be the first to receive that. So this half our time would permit. In our subsequent episode, we'll also do a quick review and on other concepts as well. Stay blessed. Bye-bye.